Okay, so now let's do some examples, right? And these examples are going to match what's in the book, right? For the most part, at least for the early parts, and then for the later ones, you know, there's some more theoretical ones, so you'll have to apply it, right? So, okay, first of all, right? You're going to have some examples if we're looking at some where you just have to sketch the ellipse. Okay, and so these ones, they're all basically the same. If you have it in a nice form for yourself, okay. So just because x is first doesn't mean it's the major axis. You need to look at what your values are going to be. So the first thing I'm going to do here is I'm going to say my center. So my center is at 5, -2. Okay, so I'm just going to list out my information. Okay, so I see that my center is 5, -2. Okay, now next thing, I'm going to do this on the side, right over here, right? I can see that my a is the square root of 20, and I could reduce it, but I don't need to. Actually, I'm sorry, I can see that what's under here is square root of 20, and what's under here is 4. So because this one's larger than this, then that means that that it's going to be in the horizontal direction because that one's larger. Okay, so this is basically telling you how far to move horizontally to get to the end point, and this is telling you how far to move forward vertically. If this one's larger, then that's A. If that one's larger, that's B. It doesn't, you don't, yeah, that's basically what it comes down to. Okay, so let's see. If I reduce that, that's 2√5. So that means that my vertices are going to be, again, going in the vertical direction, so I'm going to be adding and subtracting the A value to my center. So it's going to be 5 plus or minus 2√5. Okay, my endpoints of the minor axis, I'm going to take this and be moving in the vertical direction up and down 4. So I'm going to take this and add and subtract 4. So if I add 4, I get that, and my other one's going to be like this. Okay, right, and because I can write it as without the plus or minus, then I should. Right, this one I have, there's no real reason I can't combine these. Right, this one I can actually see those coordinates. So if I'm thinking about what I have for my graph already, right, 1, 2, 3, 4, 5, -2, so there's my center. Okay, I'm not going to label the coordinates on, I'm just going to put this, right, my endpoints of the minor axis are 5, 2, and 5, 1, 2, 3, 4, okay, so I'm just going to put E for endpoints of the minor axis there. Okay, this is going to go out about the square root of 20, right? Remember, square root of 20 is somewhere between 4 and 5. 1, 2, 3, 4. So I'm going to do right in the middle. Okay, 1, 2, 3, 4, 5. Okay, so those are my vertices. Okay, and then I sketch it. Okay, you can see that this one almost looks circular. If we were to consider the cross section of the cone, right? Remember that the cross section of the cone is, if it's a circle, it's perfectly vertical, right? So this one just is a little bit tilted, right? If we're doing the cross section of a cone, right? If we think of that, if we can visualize that cone in creating the ellipse, okay? The more tilted it is, the more elongated our ellipse gets, and the higher the eccentricity for it. Okay, we do need the foci for this. Okay, so since we have this, remember the foci are going to be inside. So b squared, since a is larger, it's a squared minus c squared. Okay, and then we have b squared, that's 16, and we have a squared, that's 20. Okay, don't use these numbers, just use these. These are the a's and the a squareds and the b squareds. So that means that c squared then has to equal 4, right? So c equals 2 for ourselves. Okay, so we're going to take, remember, and that's going in the vertical direction there. All right, so we're going to take this and we're going to add and subtract. I'm sorry, it's going to go in the horizontal direction. Right, we're going to add and subtract 2. All right, so we're going to have 7, -2, and then 3, -2. Right, so 1, 2, 3, -2. Right, 1, 2, 3, 4. Oh, I didn't make that one far enough though. Let me count again. 1, 2, 3, 4. Oh, it should have been out here, my other vertex. Oh, so it doesn't even look more. 1, 2, 3, 4. Okay. So here's one focus. There's the other focus. So I'll put those two. Okay, for myself. Okay. Okay, so there, I'm just looking at the directions of the book. Specify the length of the major axis and minor axis, the foci, and the eccentricity. Okay, so I want all of this labeled. Okay, let's label the eccentricity. So remember that if we look back at our formulas, eccentricity was C over A. Let me make sure I put that I have that right. I'm just going to double check that one. Don't use that one every day. Yep, C over A. So it's going to be 2, all right, over 2 root 5. Okay, so 1 over root 5. Okay. All right, that's our eccentricity. Okay, so if C was larger, let's say the focus was really close, right, to the A, then this is closer to 1. So the closer this is to 1, right, for ourselves, the more elongated it's going to be. Okay, so because as the foci get closer and closer to ourselves, right, as C gets smaller, right, this this ratio is going to basically be getting smaller and getting closer to 0 there. Okay, so one of the things to keep in mind when we're doing this, right, is that E has to be between 0 and 1. Okay, that if E was 0, that means that C was 0. So E equals 0 means it's a circle. Because if this focus got all the way on here, the foci in the center would be the same. Then we just have a circle there. Okay, so if E equals 0, that means that, right? That means that circle because C equals 0 and the foci are the center. Okay, and so that's a circle, right? Okay, and the closer E is to 1, the more elongated it looks for ourselves. Okay, so that's important. That's just if we just keep that in mind, that's going to help us to as we draw these, right, to just make sure ours look pretty good there. Okay. It can't be greater than 1 because if it was, that just doesn't make sense. Remember, C is smaller than A there, right? So if it was greater than 1, then the foci would be on the outside, and then we'd have a different conic section. So it just has to be between 0 and 1 there. Okay. So this is an example. This is from here up, right? There's our example. It does say what's the length of the major axis, so we can write it, right? That 2A equals 4 root 5. And that's our major axis. And our minor axis is going to be 8. Okay. I'll tell you, I don't think those are quite as significant as all the other information. I know the book's asking for it, but really, guys, as you do the examples, make sure that these are all listed. Right? I'm more concerned with these 5 things, right? When I ask for a graph on a test that we'll have on this, right, I'm looking for those. Okay. Let's see. So I showed you, hey, if there's a radical, that's fine. Here's something that can be kind of weird when we're doing examples. So example 2. I just want to point this out so that you know, no surprises. Here's a little weirder example. Okay. If we look at this one here, okay, and we're saying to ourselves, what's going on? This one's not a fraction, okay? So we can make it a fraction. We can just write it over 1, right, for ourselves, okay? And in this case, right, this one squared is 1/4, and this one is 8. Which one's larger? Now, okay, where do you get the 1/4, right? Remember that dividing is the same as multiplying by the reciprocal. So to bring this into the denominator, right, if I want to bring it to the denominator, it's going to be 1/4 in the denominator. Okay? So if I had this 3/8, then this would have been 8/3. Okay? To bring that down. So if I'm multiplying by 3 in the numerator, that's dividing by 3 in the denominator. Okay? And that's going back to some earlier math that we have. I'm looking at those two. Which one's A, which one's B? Okay, the larger one is 8, right? So, right, that's how I know it's going to be. So now I know this is going to be my my major axis is vertical. And I write that out for myself so that I remember it and I can look back at it and check myself later. So a is the 2 root 2 or the square root of 8, and b is 1/2. Okay, and then we might as well do c while we're at it. B squared equals a squared minus c squared. Right, not the prettiest math in the world. Right, I'll move the c squared over, so c squared equals 8 minus a quarter, so that's 31/4. So c equals the square root of 31/2. Okay, so these numbers can be not so pleasant. So let's list out information. Center, -1, 1. Notice that capital C, lowercase c. Right, our vertex, our vertices, we're going vertically. We're going vertically 2 root 2. So we'll take this and we'll do plus or minus 2 root 2. Okay, our endpoints of the minor axis, that's going horizontally 1/2. Okay, so take this, add and subtract 1/2. So it's going to be -3/2 1 and -1/2 1. Okay, for ourselves. Okay, where our foci going to be? Remember, major axis is vertical, right? There's my C, so I take the x just stays the same. I take the y and I add and subtract square root of 31/2. Right, there are my foci. Last thing I really have to have is the eccentricity. Take your C, right, divide by your A, right? So we're going to have, okay. Right, this is then going to become root 31/4 root 2. Can I rationalize? Yeah, I could. Is it going to help me? No, it's not. I'm just going to leave that there. Okay? For myself, right? Not pretty at all. Okay? If we think about what that value is, this one, this right here is the square root of 31, and if I put this in, it'd be the square root of 32. So this is really close to 1, so it's going to be really elongated for myself. Okay, so that's what I'm expecting. Okay, so -1, 1. Okay, I'm going to add 2 root 2, which is about, let's see, as I said, about square root of 32, so it's going up and down 5, between 5 and 6. 1, 2, 3, 4, 5, 6. So it's somewhere between there. 1, 2, 3, 4, 5, 6. Okay, going to the right and left, I mean, not very much at all. Man, look at that. Super skinny. Look at that. The eccentricity was really close to 1, so it got super skinny, right? I'm going to need to go root 31/2 up and down, right? Root 31 is like 5.5 or so, cut in half, so it's divided by 2. So that's 2.75 or so. 1, 2. Okay, for ourselves. So label vertex, endpoint of the minor axis, endpoint C, F, F. All right, that one's all set.